The greetings from K.S.Rangasamy College of Technology, myself UV, Assistant Professor, Department of Mechanical Engineering. Today I have to take the subject composite materials, the module of manufacturing. This is the fourth module of the composite material. Different types of manufacturing methods is available in the composite material. So let's see one by one. First of all, what is the molding? The process of the manufacturing is shaping the liquid or flexible raw material using the rigid frame called a mold or matrix. This is itself may have been made up of using the pattern or model of the final object. It is the first step of the molding process. The first one is a layup of the fiber preform. This is the first one, and then second one is the injection of the resin, and third step of the curing, and finally is last step is demolding. The layer of the fiber perform is we can do initially first layer of the fiber will be inserted in the molding side, and second one of the resin will be transferred from the layer side, and the third one is the curing. After we can resin will be transferred, we can do curing is the major step of the third one, and the last one is we can after the curing finally we can do demolding, and we will take the product from the last one. Next for the compression molding, this is a similar process of the last scene. Compression molding is a precise and a potential rapid process for the producing high quality composite parts in the wide range of volumes. It is typically employs the match the metal tool in the heated. It is a normally hydraulic press to the consolidate the sheet materials or molding components at a relatively high pressure. So nowadays we can do mostly using in the MOS industries side, we can using compression molding in the high quality of the product will be come from the compression molding side. This image on is A. This is for the guide pin. This one is the plastic gunners for the workpiece. This is it is a male one. Another one is the mold. These two things are the mold. We can the next B step is we can do pushing from the metal, and finally we can from the demolding from the product. So this side is the we can curing also from the this side. This is a three-dimensional view. This is a 2D. It is a upper movable mold half. It is a charging. It is a lower mixed mold half. The ejector pin from the unwanted resin will come from the bottom of the side. So this is the using of the ejector pin. The compression molding is the major procedures we got to following various things. Usually the stock of the several rectangular plies is called the charging. The ply of the dimensions selected to cover the 60 to 70% of mold surface area. The mold is closed quickly after the charge the placement. The top of the mold is lowered at the concentrate of until the pressure on the charge increase the present level. With increasing pressure, the SMC material is the mold starts from the flow and fill the cavity, and we have to maintain the temperature of the this compression molding is 270 to 320 degree Fahrenheit will be maintained, and the pressure also of the compression molding side we can maintain the 1.4 to 34.5 megapascal pressure will be maintained in the compression molding machine. After the reasonable degree of the cure is achieved under the pressure, the mold is opened and the pot is removed after the aid of the ejector pin. So this is the major procedure we have to follow in the compression molding. Major advantages of the using the compression molding offers the high volume production. Second one is the offer protection of the low cost of the components. And third one is the process offers the high surface quality and good styling possibilities. And also some drawbacks will be when the compression molding. It's the initial investment of the for the equipment and mold is high. The process is not suitable for making the small number of parts or for prototyping applications. The molding of the SMZ provides the non-structural parts, but by utilize the rights of stiffness structural member can be produced. So this is the compression molding process, the advantages and drawbacks. Next manufacturing method of the composite material is pultrusion process. The pultrusion is a continuous process used to manufacturing the fiber reinforced polymer FRP composite profile with the constant cross section. A composite is a composition material typically consisting of the thermoset or thermoplastic polymers. The reinforced with the glass, carbon, aramide fiber or combination of that. So this is the major advantages of the pultrusion. It is a continuously we can to produce the product. So that's why the pultrusion is a continuous process. The major parts is manufacturing for the using the pultrusion process for the solid drawers, hollow tubes, and flat sheets, and various types of beam, including the angle channels and at section of the wide flanged beams. So this is the major products come from the pultrusion process. This is the working principle of the pultrusion process. This is a fiber grill. These are the various fibers will come from the various grills. Next step, this is the first step, and then the second step of the guide plates. We can properly we can to allocate the fiber from the right way. So that is the using of the guide plate. And third one is the resin path. This is a major important part. Third step of the resin one. And finally, we can come from the performer and come for forming and curing die. This is the heat will be another name is the heating die, forming and curing die. We can after resin bath we go the curing is very important. So that side is the curing. Next one is the pulling sheet. Is automatically it is moved from the pulling sheet. If you are next to the final step is the cut of the shaft. So if you need the 10 meter of the product, we can cut, and another again we can cut. So everything will be operated from the systematically for the using the pultrusion process. So this is the another view for the three-dimensional for the using for the better understand of the how to processing of the pultrusion process. Next one is the filament winding process. This is the another one manufacturing method of the composites for the filament winding. So this is a similar method of for the using the pultrusion process, same working. The filament winding is the fabrication technique is mainly used for manufacturing the open cylinder or closed and structural pressure vessels or tanks. This is the process is involves in winding the filaments under the tension over the rotating mandrel. Once the resin has cured, the mandrel is removed or extracted, leaving the hollow final product. So this is the major product will be producing from the final one. It is using in the filament winding process in various industries like that automatic drive shaft, helicopter blades, oxygen tanks, pipelines, and spherical pressure vessels, and conical rocket motor packages. So these are the major application we are using the filament winding process. So this is for the working principle of the filament winding process. This is the initial step for the fiber spool. It is a comb device. Similarly, we can do using the pultrusion process method. We are using this side also. So comb devices will be moved from the right to left direction. This is the tension device. You will see properly the fiber will come with the right way. So this is the guide plate. Next one is the resin path. Again, similarly, we are using the resin path. The fiber will be come with the resin path side, and next we go to find the they are pair to of the pipe. And this is the mandrel. This mandrel is moving from the clockwise direction and anti-clockwise direction. Usually rotation. This mandrel will move from the right to left movement. So finally the product will come from we can do dismantle and finally insert from the new product. So this is the another view for the filament winding process for the three-dimensional view. So this is for the rotating mandrel. These are the method for the manufacturing of the filament winding process of the composite material. Major advantages of the filament winding process for certain applications such as pressure vessels, fuel tanks. This is the only process can usually produce the cost of effective high perform parts, utilize the low cost of raw material and low cost of tooling. The process can be automated for production with the high volume products. These are the advantages and some drawbacks also available in the filament winding side. The maximum fiber volume fraction is attained with only 60%. Compared with the pultrusion process, this one is a low one. And also another one drawback is difficult to obtain the uniform fiber distribution and resin content throughout the thickness of the laminate. This is the drawbacks of the filament winding process. Next important method for the manufacturing of the composite material, particularly for the metal matrix and the ceramic matrix composite manufacturing method, is the stir casting method. So stir casting is a typical casting process in which the mechanical stirrer is introduced for the vortex to the mix the reinforcement in the matrix material. The mechanical stirrer is used to from the vortex which the leads to the mixing the reinforced material which has to introduce the melt. So this is the step-by-step procedure. Initially melting the matrix material is the first one. Second one step is stirring the molten metal by using the mechanical stirrer. And third one for the feeding of the reinforcement material. And fourth one is the continuous stirring mixing the reinforced metal. By you can using the adding the filler material. For example, aluminum matrix, we can using the shear casting method, we can using the some filler material, titanium oxide, aluminum oxide, or zirconium oxide, silicon carbide. So these are the filler material we can adding in the metal matrix side. The we can do strength wise will be improved. Nano materials also we can using the used for the filler material of the metal matrix composites. The finally is a puring of the mixture in the mold, and finally come from the solidification. Solidification is the last one. So this is the process of the stir casting method. So this is for the uh, mechanical stirrer. Matrix metal will be then will be continuously stirred. Will be connected with the ultrasonic power side, and ultrasonic transducer also we can use. Sometimes for the mechanical stirrer or ultrasonic transducer also one type of stirring purpose for using. So this is where manufacturing of the metal matrix composite material using this stir casting method. Thanks for watching video. Keep learning and grooming. Thank you.